Welcome to CHE124 General Chemistry 2 Laboratory. This week's laboratory is a study of Beer-Lambert law. The Beer-Lambert law relates the absorbance of a solution to its concentration. The E is referred to as the extinction coefficient, and B, the cell width. These two are fixed in our experiment, or a constant, and so then as we increase the concentration, the absorbance goes up. As we decrease the concentration, the absorbance would go down. We can take standards, right, and prepare known standards, and then measure their absorbance in a spectrometer. We could use something as simple as a colorimeter, and that would work well for copper sulfate solution, or we could use something like a atomic absorption instrument. In fact, we will use both of those instruments for today's experiment, so we'll get that opportunity. You could also use the scanning UV vis spectrometer that we're using for the phosphate lab to do this experiment. So we'll look at those and do our measurements with those. So the objectives then are to prepare those standards. Right? I want you to prepare 5 standards of copper 2 sulfate, and then we're going to analyze those. So that the first way we're going to analyze it is in the cuvette, which is non-destructive, and so I would want you to do that experiment first with the colorimeter or scanning spectrometer. The second experiment we're going to do with the atomic absorption instrument, which actually destroys the sample, and so it's a destructive method, and so we'll do the analysis on both of those, and we'll end up with 2 different standard curves. And then we're going to take an unknown, so we have prepared a solution that the concentration will be unknown to you, and you're going to analyze those for the concentration and use your calibration curve to find that. And it's the same process that we're going to be doing for the semester-long project with the phosphate ion. And so I want you guys to practice making standard curves and analyzing those to help you work on your ability to measure, right? This is a relationship which I want you to see. It's nice to see it from this perspective, but transmittance versus absorbance, right? And so the top row of numbers is the percent transmittant. When 0 light is transmitted, then you have an absorbance that's greater than 2. But when I go to the other end, when I have 100% transmittance, then 0 light is absorbed. And so those are related. They're actually related mathematically, right? And so, or actually I want to go drop down to this equation, where absorbance is equal to 2 minus the log base 10 of the percent transmittance. And so you can work back and forth between the 2 scales with mathematics. And so anyway, but absorbance is the unit that we need to use for today's experiment because it's proportional to the concentration. So it works for our measurement in that. All right, so you're going to prepare 5 standards. These are the concentrations or the standards that I would like for you to make. And so it's asking you to take a stock solution, a 0.4 molar copper sulfate solution that we have prepared. And for the first one, you're supposed to take 2 milliliters and dilute it to a total of 10 milliliters, and that'll give you a concentration of 0.08 molar, and so on. And so these are the 5 standards that I would like for you to utilize in the experiment. Okay? We have prepared your unknown to be inside of the low standard and the high standard so you can interpolate to find your answer. It's not common practice in analytical chemistry to extrapolate or to go outside of those values to predict a concentration. What we would do if it were outside of that is to make an additional standard that would be on the outside or be put on the outside of our unknowns point. So anyway, something that you'll need to consider for your environmental project. Okay, so glassware for solutions in analytical chemistry. There's different types of glassware. All right, beakers and graduated cylinders are less accurate than things like burettes, pipettes, volumetric pipettes, and volumetric flasks, fixed volumes. And so I want you guys to learn to use the appropriate glassware when we need a higher accuracy, all right? And so if I have a variable volume that I need, then I can use something like a Moore pipette, or if I know the density of my solution, I could actually even weigh the amounts of material to make that the right ratio. And so that would be a very accurate way to do it. If I'm doing fixed volumes, I do volumetric flasks and volumetric pipettes. And other things that are really important to make sure there's no contamination, especially in low concentration standards, we want to make sure we triple rinse all our glassware with deionized water. So if there were any residue from a past experiment, those types of things, then we would be sure and remove it. So things to think about, all right? Data collection. You're going to collect the absorbance versus concentration, right? We're going to do the same type of experiment that we did with the phosphate lab, where we're going to take our color solution, we're going to scan the spectral, or the spectrum from 400 to 800 nanometers in the visible part of the spectrum, and we're going to find the peak absorbance, maximum absorbance, and then we're going to set our instrument to that and run our samples to create a calibration curve, right? And then we'll run our unknown, and we'll use the calibration curve to determine the unknown's concentration. Now, the AA, atomic absorption spectrometer, destroys the sample, so you'll want to do the one that does not destroy samples first. This is an example of a calibration curve. This wasn't done with copper sulfate. It's actually a protein in solution, and what we see is that the protein absorbs related to the changes in concentration, and it's linear from no concentration to 25 micrograms per liter, and so we could use this to talk about the concentration of that in solution. Our linear equation, we've seen this so many times, I feel like you guys know this. Y would in this would be the absorbance, the X would be the concentration, and so the slope of the line on the previous graph is the calibration curve, and I would take my unknowns, absorbance, plug it in here, and then solve for X to find the concentration of the unknown. All right, so to complete the lab, we're going to answer all the questions at the end of the lab, turn it in next week, and for safety, the chemicals are safe to handle. You shouldn't touch chemicals, but if you did get it on you, rinse that off with water and practice good safety. Have a great day, and I'll see you in lab.